Hi, how's everyone doing? Hope you don't mind that I do this in English, because live coding is really hard and I want to challenge myself. The talk today is called Going Commando, a serverless multiplayer game. And we'll actually be building some sort of game together. And by together, I mean me. Okay, so my name is Opher, and I work at Interlude. I'm a creative developer there, and we're doing really cool stuff with interactive video, which has a lot to do with the games, but not with this one. What are we doing today? So we'll be building a game with Phaser and Firebase. It will be entirely in JS. It will be serverless, kinda, and we'll see what that means in a second. And you have to participate. I'm warning you. So you'll need your phone, and if you're not on the Wi-Fi yet, then do so now. So what is Phaser? Phaser, it's a JavaScript library that's open source. It's mature. It's been around for, I think, 3 years, if not more. And they have really good tutorials and examples, and people do really cool stuff with it. Firebase, so it's a backend as a service. You use it as a database. And the cool thing about it is that it's real time. You got a simple JavaScript API for pushing, for fetching data, and it all happens really fast and in the client. Okay, so what are the rules of the game? We have 2 screens. One is this screen over here, and the other is your phone. There's a game board that's X by X grid, and each player controls 1 commando. Now, commandos can move 1 square in any direction, and when 1 commando touches another, he kills him, and then the other commando drops underwear. That's the game. And commandos can't walk on the underwear of dead commandos. So here's a typical multiplayer game architecture where you have your clients connecting to cloud endpoints, and then you have matchmaking servers, and you have world servers, and yeah, we're not going to do any of that. We have something pretty simple. We have a desktop, or actually a laptop. That's my computer in this case. We have Firebase. And we have the clients, which are your phones. And that's pretty much it. So how does it work? Well, the game state is saved on my computer. So it essentially runs the game. And your clients send their requests or what the commandos should be doing to Firebase. And then my desktop consumes these requests and updates the game world accordingly. So essentially everything is saved on my computer, and only the commands go through Firebase. Okay. This architecture is not something you'd use for an actual game, simply because it doesn't deal with really, really important things like making sure that your users input valid commands, or that nobody's trying to hack the game or something like that. And it doesn't deal with lag, which hopefully we won't see here. And conflict resolution and a lot of other things that games actually need, multiplayer games actually need. But it works, and we'll be doing this, so that's cool. Right now, what I have here is just the images that I'm going to use pre-encoded to base64. That shouldn't concern you. That's just because of the live coding. And let's start. We need the grid size, for example. Let's put it at 10, and we need something for the square size. Let's put it at 50. Now let's create the game with Phaser. So we do Phaser new Phaser game, and then we give it the height and the width. So that is grid size times square size. Then we pick a render, which could be either a WebGL or Canvas. We'll just use Auto, which Auto picks for us. And then we give it a name, like my game. And then an object with two functions. One is the create function that happens when the game starts, and the other is the preload function, which happens before the game starts. Let's do those now. Cool. Now we should be having nothing, which is exactly what I wanted to have. We have this black square. This is where the phaser canvas lives. Let's start by loading the images. Game load image, and we give it a name like grid, and the actual image. And let's load the Commando as well. So by now we only preload the images and we don't have anything else. Let's start by actually creating the world. So we're iterating on every square in the grid. And we'll be creating the grid. So for, let's do square equals game add sprite. And we give it the x and y coordinates, which are x times square size and y times square size. Square size. And which sprite do we want? In this case, we want the grid. A sprite is a name, as a general name for an object in the game. So we see that the size isn't quite the size that we want. So let's just fix that. Yay, and now we have a game board. Cool, but let's put something in it. For that, let's create this ugly global variable, which we will call Commando. And let's create a new Commando. So Commando equals game add sprite. Put it 0, 0, and the image is named Commando. And yay, we have a Commando here, but it's, again, not the right size. So square size. Okay, so we have a Commando in the first square. But let's make it more interesting. Let's move it around a bit. So let's create the function move right. And here we're creating a new tween, which is the way we can animate objects in the game. One of the ways in which we can animate objects in the game. Other ways are using physics engine or using some other methods. This one is used for graphics, for example. So game add twin. And we tell it where exactly to twin. Then we tell it to start. Let's see that it works. Yay, moves. But it's a bit slow, so let's give it some smaller amount of time. Okay, that's not very interesting. Let's tie it to some sort of input. Let's say, for example, the right key. So game input keyboard, add key, and the key that we want is phaser keyboard right. And then we can attach a handler to this key down, add, move right, and the context. This means I made a typo. No, it's on down. And we have something moving, and it's actually working, and I did that live coding, so I'm very proud of myself. Wait, you haven't seen nothing yet. So that's one part. We have a commando, and he's moving using the keyboard, but that's not really what we wanted. I promised you, a multiplayer game. So let's start with the other part, which is how you control the game via your phone. So this is a simple UI that I built. As you can see, you only have a bunch of divs here, each for its own button. And this is where the magic happens. So as you can see, nothing happens here. We don't have any logic. But we'll start by building the logic. So we start with Firebase. So we do create an object called orders reference, which is a new Firebase, with a URL for where I put my storage. So HTTPS going Commando at firebase.io/demo/orders, and everything after firebase.io.com. Everything after the .com is arbitrary. You can use whatever you want, and you'll see it in the database. And I'll show you in a second. So we add an event listener for the button. So document body query. And event listener, click, function, then we want to actually make a new order every time someone clicks the button. We want to add another order to the queue. So what we do is we make a new order, orders ref.push. This means that we'll get a reference for a new item to be put in the database. It's not there yet. It will be there in a second. When we do new order dot set, and then give this object something like direction right. Okay. Now let's see how that looks in action. Let's go to the same URL. So Firebase going Commando. So the URL is going commando.firebase.io.com/demo. This should be touch start, because on the phone the click might not work. Let's see if it did something. Yeah, okay. So you see, I click here on my phone, and more commands are being added. And each command is an object with a key and with the same thing that I just put in. So just immediately out of the box, I have something going from my phone to some server somewhere without touching any server code at all. I click here, new orders are being added. Okay, so up until now, we had this commando which moved using the keyboard, but let's do something else. Let's move it using commands from the phone. So our orders reference will be a new Firebase with HTTPS going commando firebase.io.com/demo/orders. And now I want to attach a handler to this thing. Before we do, let's make sure there aren't any standing orders from last time. I don't want to replay every order that's ever been there. I want to remove all orders when this game starts. So I did ordersref.remove. And now I can do ordersref on child added function snapshot. And what this does, let's see. Okay, snapshot means the value of the data as it came from the server. I just got this value, and the data, the value of data might already be changed in the server, but this is the data as I have it right now. And then we can check if the snapshot value direction equals right, then move right. We have something moving. Okay, but I kind of lied to you because this is not a game. It's just a command. He's even moving in the wrong direction. Let's fix that real quick. So commando.angle equals 90 because we want this poor little guy to see where he's going. So let's do that again. Okay. So now at least he's facing the right direction. There's more work to be done. There is saving the game state because right now nothing tells us where the commando is. There's registering different players, and there's implementing player collision. So I'm not going to write it, but I am going to show you how exactly that works. So saving the game state is pretty simple. I just have a two-tier array for each tile in the game board where I initialize it to be the string empty because there's nothing in there. And then when I move a commando, I just give the function the name of the sprite in phaser, the x coordinates that I want to move it to, plus the y. And then I can check whether the commando is in the game bounds. And if it's in the game bounds, if it's not in the game bounds, I just return. The function does nothing. If the game board has some sort of enemy in it or something else, then I can run the kill command function. So essentially, it's just a simple array where I put all the game data, and that's saved on this computer in the client. Let's talk about adding players. So if I wanted to add a new player, I would just have another URL pointing to a data section in Firebase. And then every time I want to create a new player, I do new player reference equals to a new player.push, which is exactly what we did with the orders. And then I can give it a key, which is the key you saw earlier in Firebase in that list. And then the server here, which is my computer, only has to handle, in the same way it handled orders, needs to handle new players and add them to the game. Let's see how it does that. It looks like all code, but it's really simple. So again, I remove everything that was there before in the previous game because I don't care about it. And then on child added, which means every time something new gets added to that location in Firebase, this gets called. So in this example, it will be when something gets added to /players, this will get called. And I just run the make new commando function with the ID that whatever ID or color that I want. And here, all I do is create a random position for the grid. And I add a new sprite, like I showed you earlier, with the random position, change the width, change the height, save the grid position. And the only thing here that's a bit different, or added, is that I need to keep an array of these commandos just so that I can increment their kill count or whatever. So using Firebase for games, it's really good for games that have high latency. That means that not a lot of data goes between clients. So games like chess, Hearthstone, Clash of Clans, if you know it. So games that are not really intensive, that everything keeps moving all the time. It's a bad match for players with games with low latency, like Rocket League that relies on physics, World of Warcraft, Call of Duty. Like I'm giving you these big names that you can't, will be hard to implement in the browser. But essentially what it means is that if you have a lot of things moving at the same time, you will need some way of optimizing the netcode so that you only pass the minimal amount of information via the wire. And it's going to be hard to do that in optimization with Firebase, even though it's possible, but it will be harder. And you need to use authentication. So in this example, there was no authentication at all, and someone could just as easily open up this a Firebase account and just change stuff on my database. Obviously, that's not something that you want. So authentication, important. Okay, you guys ready? You don't sound like you're ready. Are you ready? Yeah. Okay. So this is how it's going to be. You need your phones ready at hand. And then I'll open up this game. And as soon as you connect with your phone, there's going to be a URL at the bottom. As soon as you connect to your phone, you're going to get a color for your player on your phone, which will be the same color on the screen. That's how you're going to know which commando you are. And once you're dead, when someone touches you, you're dead, and that's it, and you're out of the game. Okay? Let's go. Okay, we have our first players. Okay, the green one has 3 kills. 6 kills. Someone's on a row. Mysterious green player challenger. Yeah, that's that guy over there. Woo. Thank you guys very much. I was Opher. That's how you contact me. So let's give it up for CodePen. So it's a website that allows front-end engineers to just do sort of experiment with HTML and CSS in the browser, and that when you go on that website, you have like it's called CodePen, codepen.io, and you get all sorts of really cool front-end engineers doing crazy stuff, and the cool stuff gets picked, and it's kind of like a playground for front-end engineers. So the question was that I claim that Firebase is not so great for low latency games. An alternative would be rolling your own server that handles proper netcode. It will have to deal with a lot of things like keeping a concurrent connection between the players and the server, lag, prediction, validation, sharding if you have different game worlds. It's just, I could do a whole talk on how to do just that. And in a multiplayer game, the netcode or the server is the most complicated thing. And the game doesn't even, regardless of the game, the server code is awful. And that's why I think this is so cool, because as you can see, just in 10 minutes, I can do something that actually works for those things. Yeah, so the question was, how do you get this on the server without you having to actually have a laptop running your game? So if I wanted to use that, I would actually have a server, some sort of real server that connects to Firebase and then updates Firebase or uses Firebase to get the messages across. But it's a server, not a personal computer. So it could work on Node or something that has JavaScript interface. Though I think Firebase have interfaces or APIs in other languages as well. So we could just need to see their documentation. Firebase has great documentation, which is a good thing in general. Thank you guys so much.